Oh, hi everyone. I have detailed the PC software in the Instructable and probably in anything else I subsequently write up. But I thought I would do a little video to demonstrate its operation because I think as they say, a picture paints 1,000 words, so it's easier to comprehend what's going on if you can actually see it operating. So the hardware is up and running. And essentially just sitting there waiting for instruction, and I've just fired up the PC GUI that I've written. So this is what I've called the WSPR or WSPR control panel. This is written in C# under a Windows environment, as opposed to the firmware running on the PIC microprocessor, which is written in C and then subsequently compiled using the microchip C18 compiler with optimization. Anyway, so this is the PC GUI. So this is the control aspect of the WSPR Beacon, and it's communicating with the hardware over a 433 meg serial radio interface, which I kind of quite like. If I can remove wires, I'll replace them with radio at every possible opportunity. So I'll quickly go through this. As I say, it is in the documentation, but I'll go through it. So we've got a COM port box up here, which all the settings that you see here are remembered. They're not stored in a file. They're stored in a settings class, which is part of the sort of C# environment. So there's no additional files written. It's all stored internally. So for example, COM port 2 has been remembered. There's other COM ports, but because I used COM port 2 last time, and that's what the hardware's hooked to, that's what it's remembered. And then there's an open port button, which is not. I haven't opened the port yet or done anything. I've just invoked the software. This box here is the TX message. So we've got my call sign G7IYK. I'm only supporting the single pass transmission mode. I don't think that the two pass transmission mode is really used all that much, and I didn't think there was much point going to all the extra effort of supporting it if nobody was going to use it. That's my call sign, which is the sort of 4-digit Maidenhead locator for for roughly where I live in Bristol, and then the power. So I'd say the RF power amplifier is generating about 2 watts, about 33 dBm, something like that, and but after cable losses and antenna mismatch, I say I'm probably radiating about 30 dBm or 1 watt. So you've got a pull down here. You can go from 20 dBm 100 milliwatts to 40 dBm 10 watts. I mean, I can add more. I didn't think anybody on this mode would probably be radiating more than 40 dBm. I wouldn't expect. Well, certainly I've never seen anybody being reported radiating that sort of power. Then this box here, this is this frequency band control. So I'll quickly explain this. I've done the best I can to make this as simple as possible, but obviously it might be confusing. So we've got all the bands. We've got the bands I've chosen to support, which is 10 to 80 meters. My antenna's really I've got a offset center fed dipole, which is kind of tuned for 20-40 meters. It's miles out on 30, and I haven't tried it on the other. So I mean, if you've got an antenna system that supports all these bands, then you can tick as many bands as you want. So I've just ticked 20 and 40 because I know that I've got a good antenna match at those two wavelengths. So this frequency hertz here, this is the WSPR band is, as I've said in the documentation, is 200 hertz wide. The transmission bandwidth is 6 hertz or approximately 6 hertz. And the bandwidth which you transmit in is 200 hertz wide. So this frequency in hertz is the offset that you wish to transmit from the bottom of the band. So if you put in 0, you'll be transmitting at the bottom of the band. If you put in 200 at the top of the band, and this is in the middle of the band. Okay, that's all clear, I think. This box over here is step hertz. If it's 0, it means you want to just transmit on a single frequency. In this case, it will be the middle of the band, 100 hertz. If you've got anything other than 0 in here, you're telling the system you want to operate in like a band scan mode, and I'll explain what that means. Say I put 10 hertz in here, and I put 0 hertz in here. What this is going to tell it to do is start at 0 hertz, bottom of the band, perform a 2-minute transmission, increment up the band by 10 hertz, perform another transmission, and so on. So it'll step up it'll start at the lowest wavelength, or the shortest wavelength, 10 meters or whatever you've got ticked, in this case 20. It'll start at the lowest wavelength or shortest wavelength, and it will step up the band in whatever you put in here. The minimum is 10 hertz, and I think the maximum I've decided was 50 hertz, because 50 hertz would give you 0, 50 and 150. I can't remember that, it might be 100 hertz, but basically 10 hertz will go 10, 20, 30, 40, 50 all the way up to the top of the 20 meter band. Then it will automatically switch to the 40 meter band, start at 0, 10, 20, 30, 40 all the way up the 40 meter band till it gets to the top. Then it will go back automatically to the 20 meter band and just cycle, so it will cycle 20 and 40 meter band in 10 hertz steps until you stop it. So if we want to transmit on a single frequency to 100 hertz, and we do 0 in there. I think that's fairly straightforward. I can't see that's confusing, but probably will be to somebody. Now down here we've got this box here is it seems to be a repeat of some of this other information, but it's not. It is in that this is the information which is reported from the hardware. So when I press the send button in a minute, after I've opened the port, all this information is sent to the hardware over the serial radio interface. The hardware acknowledges receipt of that information by echoing it back to the PC on the uplink, and then as the information is echoed back to this control panel, it populates this panel here. So what you'll see is this panel being populated as the hardware acknowledges the receipt of the information, if that makes sense. This bar here is when we're actually transmitting, is the number of symbols we've transmitted from 1 to 162. So it's like a progression bar, so you've got some idea where you are in the 2 minute window. Little by me kind of icon down here. GPS status will be locked or unlocked. Transmission is dependent on GPS lock. The PC time is not used at all. It's all based on the GPS receiver on the hardware. So if it hasn't locked, then it won't transmit. So that will be locked. GPS time is the time. That's not the time on the PC or the time anywhere else. That's the time being reported by the GPS module on the hardware. That information is sent over the radio link, the telemetry radio link, back to the PC once per second, and that's what's in there populated. Okay. Oh, I forgot at the very top here. This debug window. This second window here is the debug window, which sort of shows you what's actually happening in terms of communication between this software and the hardware. If you don't want to see it, then you just untick this or uncheck this, and you don't see this second panel on the left here. Right, quickly look at the WSPR calibration. Okay, so we've swapped over to the WSPR calibration panel, which was the second tab on the top of the screen. This panel essentially contains two pieces of information. Before I get going on explaining what this is all about, I ought to point out that the AD9850 direct digital synthesis module has an onboard 125 megahertz oscillator, crystal oscillator. Now these modules are pretty cheap. They're like £3 to £12 depending on where you get them. So the accuracy of that module is not going to be terribly good. It could be, a few tens, maybe even hundreds of ppm out. The upshot of that is that any inaccuracy in that crystal oscillator reference will have a direct impact on the accuracy of the absolute output frequency. So if you tell it to go to 14 meg, for example, then it will be 14 meg plus or minus whatever the inaccuracy in the 125 meg reference was. And that was the case with the module I've got. When I first used it, and I was programming up for particular frequencies, and it was out by a little bit. In the case of the module I've got for 20, 30 and 40 meter bands respectively, I was out by 76, 60 and 44 hertz high, so it was consistently high in frequency. So I've included these input panels for all the bands to allow the user to program a plus or minus offset in order to pull the module back on frequency. So in my particular case, I've programmed up offsets of minus 76, minus 60 and minus 44 hertz for the 20, 30 and 40 meters bands respectively, which now pulls the module pretty much back onto frequency, adds an offset to how it's programmed. Now these modules will drift with time, based on temperature, aging effects, various other parameters. So you could potentially expect a drift of 1 or 2, maybe quite a lot of ppm per annum, depends on the conditions. So these offsets will need a readdressing at some point, if you're that bothered. So that's frequency calibration. And now the second parameter is the filter position. That's not strictly to do with calibration, but it just seemed a convenient place to put it. So for every band, we've got a little box on the right here with a number between 1 and 5, which corresponds to the 5 possible physical filter, low-pass filter positions in the relay switching module, which sits on the output of the PA. So I've only got a 20 and a 40 meter filter fitted, so all the other bands are just set to 5 for want of a better number. So the 20 meter filter is in position 1 and the 40 meter low pass filter is in position 2. So once the software has been informed of those positions, whenever that band is used either standalone or as part of the band scan function, the hardware will automatically switch in the appropriate low pass filter to snub second harmonics and further harmonics down the band. I hope that makes sense. Okay. Enough wittering, let's actually get it to do something. So the first thing we have to do is open the COM port. Okay, so as soon as you open the COM port, then you start seeing some telemetry coming back from the hardware. So COM port was opened. In this debug, a lot of this is for my benefit because I was obviously writing the software. So I just thought I'd leave it in there because it allows me to see what's going on, and I thought maybe other people might be interested. So at the moment, all it's doing is the hardware is sending back the time and the fact that it's locked, and at the moment the symbol is 0 because we're not transmitting anything. So that's just kind of like it's just going to sit there and do that. And you can see here that down in the bottom boxes we've now got a locked icon showing the GPS status is locked and the current GPS time reported by the GPS module of the hardware. All good. So now we don't need to do this every time. I stress that once we configure the hardware, it remembers the settings. So when you power the hardware up the next time, you don't need a PC connection. It will remember all the settings, and if you push the transmit button, it will transmit whatever it was told to transmit last time you set it up. This is a demonstration of what you do like the very first time when there's no configuration in the hardware at all. Okay, so if we hit the send button, now we're connected. There we go. So all these fields have gone green. They've gone green, indicating that the information was sent to the hardware, and the hardware successfully acknowledged all those fields, and they all matched. They were all correct. And the bottom box is populated by what the hardware actually acknowledged. So we've kind of almost got a copy from the top to the bottom. What we sent, what was received, and everything we were sent. Everything we sent went green. If we go to the calibration state, that they all went green as well, because all these calibration values get sent as well and remembered as well. So they've all gone green. So everything's green. So that's it. The hardware is now configured. So if we enable transmission, and it will also show you that the last band that was used, the last band it transmitted on in this particular case was 40 meters, but it will start at 20 now. So if I enable transmission, so it's now waiting, because Whisper only starts transmission on the top of an even minute. Yeah, if that makes sense. So it doesn't just start transmitting, because everything has. That's why we're using a GPS lock. So here there was a lot of debug information, including the frequency. That frequency base is the actual tuning number for the module. It doesn't mean much. It's just a big number. We're going to start at an offset of 100. Step is 0, and the calibration offset was -76 hertz. So now it's sitting there waiting. So we're at 5 minutes. So when it gets to the top of this odd minute, or it hits the top of an even minute, it'll start transmitting. There. So even minute top detected. and we're now transmitting. It's now the hardware. I mean, I'll put a little inlay of the picture, but the hardware, PA, RF power amplifier, power light has come on, and you can see the progress bar here is progressing from left to right. And if we look at the debug information, we can see not only the symbol. I know it's buried. It's reporting time as it did before, locked. And it's reporting debug symbol, the symbol number, and then this is the data on the on the right hand side of the debug here. This data value, you see that they're either 0, 1, 2, or 3. Those 0, 1, 2, or 3 values correspond to the 4 FSK symbols that make up the WSPR protocol, or transmission protocol. So that is the WSPR sequence for G7 IOIK, IO81 and 30 dBm. So this is I'm currently radiating this. So if we just wait a second, so you can see that the current band is correctly switched to 20, and the current frequency is 100 hertz. Now it'll just do this now over and over and over again. So we'll wait till it gets to the top of this. Fortunately, we've got to wait 2 minutes, which is it's just the way it is. I'll demonstrate this one single frequency, and then we'll stop it, and then I'll just quickly demonstrate the band scan, and I think that'll probably be enough for everybody, including me. So we're reaching the top now. 48, 49. There. So it's started again. So if I stop it, it will start. I'll stop it before it restarts. So if we put in 0 hertz here, and a band of say 10 hertz, I resend that to the hardware, configure the hardware, enable transmission. Now we see that the current frequency is 0, because it's going to start at the bottom of the band, because we've configured it for like band scan mode. So again, it's going to wait. I don't know whether I should just wait, because it's obviously going to take minutes of time. A little drink while I'm waiting. Now, if anybody has got any comments on this control interface, I mean, the thing is, a control interface is in the eye of the beholder. So this is the way I've set it up, but that's not to say everybody is going to like it or think it's appropriate this way. It's just the way I configured it. So if anybody's got any bright ideas that they think might enhance it, that I haven't included because I haven't thought of it, then just let me know, and I could build it in. I mean, for me, it seems to do everything I want it to do. I can set up the bands, I can put it into a scan mode, or I can transmit on spot frequency. I can let it run in. The only thing I did think I could include that I haven't included at the moment would be a sort of a transmission schedule mechanism where you could program it to transmit at certain times of day or night, or any time you wanted. Right, it's just about to start the first transmission at 0 hertz, band 20, 59, to take the top of the minute now. Okay, so now it's actually transmitting, so we'll let it sit there. Yeah, going back to this, I've got a module or a module here lying around somewhere, which is a real-time clock. It's really accurate. It's not as accurate as GPS, obviously, but it's pretty accurate. It's within a few ppm. It's going to not lose more than a few seconds from time to time. I could easily hang that off the microprocessor, and then effectively you could configure transmission starts and stops, put in as many times and dates as you wanted, and it will just, once it's programmed up, it will automatically start transmitting, almost like a kind of a transmission alarm clock, if you like. That would be fairly easy to do, and with the module bolted onto the microprocessor hardware, you wouldn't need any PC support. Once you've programmed it up, it will just sit there and do its own thing. So that may possibly be one enhancement I might add on, if there's kind of any interest in that. So it's just over halfway through its first band scan transmission. I know this is dragging on a little bit, but unfortunately that's the nature of WSPR. You have to wait 2 minutes for it to finish. I suppose I could just fast forward the video, but that might prove a little bit confusing. So we've only got about another 30 seconds of wittering, and then it'll all be over. This transmission is actually, I am actually radiating from my antenna, so I'll be getting hits on this. Right, so it's coming to the end of the transmission, and you'll notice now that the current band is still 20, but the current frequency is now incremented from 0 to 10 hertz. So it's now going to start its second transmission at an offset of 10 hertz from the start of the WSPR band, and it will then go 20, 30, 40, 50, all the way up to the top of the band, and then it will flip to 40 meters and do the same. Okay, I think that's probably enough of this, of me. Yes, any suggestions, give me a shout. In terms of stopping the transmission, you can either press the button on the hardware, which will immediately stop the transmissions, or if you're connected to the PC, just hit the TX enable button again, and it will wait to the edge. It will wait to the next GPS edge, and then it will wait to the edge of the next symbol, and then it will cease transmission. So it's now not transmitting, hence it's gone red, and our symbol progression bar is not illuminated at all. So that's basically it, really. Yeah. So say with the debug window, if you don't want to see the debug window, you just do that and it goes away. And it's simple as that. Okay. Anyway, sorry that went on a little bit longer than I anticipated, but yeah. Thanks for watching. Cheers.